Hey everyone, this is Rohan Shah with BestEconTutor.com, and in this video we'll be talking about the production function, average and marginal costs, and returns to scale. So, first of all, what is a production function? Basically, imagine you're a business. Let's say you're Ford, you're making trucks. Now, the production function is basically telling you how many trucks you're able to produce based on how many workers you have and how many machines you have. Now, the machines and the workers, those are things that you're going to use to produce your output, your trucks. So those are usually called factors of production. Now, the notation looks something like this. Now, might look confusing at first, but let's break this down. What does this really mean? This is just saying that the quantity, that's the trucks that you're able to produce, is a function of, that's just a fancy way of saying it depends on, the number of workers you have, and K, capital, that's just, the best way to interpret that for this course is really how many machines you have, or non-human resources, machines, that you're going to use to make your output. And this is the human resources, meaning labor, that you're going to use to make your output. Long story short, let's say we know that 10 workers and 15 machines will make you 100 cars. That just means that 10 workers and 15 machines, if you have 10 workers and 15 machines, that outputs a quantity of 100 cars. Now, you probably won't need to know exactly how to do math with this multivariable thing. This is just really kind of a way to phrase what's going on here. So, in the production function, the capital, usually in the short run, is fixed. Means that you usually can't buy extra machines or get rid of machines in the short run really easily. But we assume that you usually can do that with workers. You can easily hire workers or get rid of workers. That's the assumption. So, in that case, one variable that we look at is called MPL, marginal product of labor. What that really says is how many units of output, so in that example, how many trucks did the last worker make? So, for example, let's say we have these data points. L is the number of workers, Q is the number of output, meaning trucks in that case if you're Ford. Let's say we wanted to find what the MPL was, marginal product of labor. So again, marginal, just like with every other place in economics, marginal just means one additional, or the last one or the next one, either way. So if we wanted to figure out, and usually you can assume that 0 workers makes 0 output, even if they don't give that to you. So here we can see then that the very first worker made 10 trucks, so that's 10. The second one alone made 8 because that's how much the output went up by. So you can really say that the formula is change in the quantity divided by change in labor. Now here's one thing. You might look at this and say, if 2 workers made 18 trucks, doesn't that mean they each made 9? 18 divided by 2? Well, what that's saying is that the average is 9. So there's this new variable also called the average product of labor. That's really just saying, on average, how much did each worker make? And that's really the formula for APL is simply Q over L, not the change. So that you can say that on average here, that is 9. And here, for one worker, that's 10. So here then, if we're doing the marginal, the third worker alone made 3, because 18 to 21. But here you're just doing the average. 3 workers made 21, so 21 divided by 3 each, on average, made 7. So here's the thing, just because you know the APL, meaning on average, each worker made 7, doesn't tell you how much, what the breakdown was, how much each worker made. And usually what we're going to observe here is that the more workers you have, each one's going to contribute less and less. That's called diminishing marginal returns. That usually happens, imagine if you own a restaurant, you hire one chef, they're probably going to make a lot of food, a lot of dishes, But if you're at the point where in that same one restaurant you're hiring a 14th chef, probably not adding a lot. So that's why the marginal product of labor usually is decreasing. Now let's talk about average and marginal costs. One quick point, the difference between the word price and the word cost. In English, they're often interchangeable, but in economics they mean different things. Price is what the customer pays the business. That's usually the equilibrium price, that's where supply and demand intersect, but cost is what the business spends to produce the good. So really the word cost is only talking about the business. So now let's talk about these new variables that we're going to learn. There's a lot of different equations, but you don't really have to memorize all of them. You can kind of understand where a few of them come from, and then the rest you can kind of, manipulate and, deduct from the other ones. So it's all about understanding a few basic concepts, and then, it should all fall into place. So first of all, let's look at the difference between fixed cost and variable cost. Now, let's say you have a fork factory. You produce forks. A fixed cost is something that you're going to, as a business, have to spend the same amount regardless of whether you're making one fork or a million forks. So, for example, rent. If you have rent to pay on your factory, the space that you're renting from some landlord, whether you choose to make one fork in that whole factory space or a million forks, you pay the same amount in rent. So that's really a fixed cost. It doesn't depend on the quantity. So that's really how you can define fixed cost. It's something that does not depend on the quantity produced. Variable cost is simply something that does depend on the quantity produced. So, for example, you'll probably hire more workers if you wanted to make a million forks instead of just one, and that's why labor expenses are a variable cost. And really, at that point, you can kind of, for any single expense that you have, you can ask yourself, will this be more of when I have more forks, or does it not depend? And that's how you can know whether it's fixed or variable. Total cost is just the sum of your fixed costs and your variable costs. If you add those two up, that's really the total cost of making those forks. So now, from that, we now talk about average costs. The average total cost is simply the total cost divided by the quantity. Quantity meaning the number of forks that you made. Average variable cost, as you could probably guess, is VC over Q, and that is FC over Q. So really, that's the thing about these, where for all these, the average is simply that divided by the quantity. Now, there's another equation we can come up with. ATC equals AFC plus AVC. So looking at that first equation where the fixed and variable add up to the total, well, the same is true for their averages. The average fixed cost and the average variable cost add up to the average total cost. The reason is simply, if you start with this equation, if you divide both sides of this by quantity, here you'll get TC over Q, which is ATC. And here you'll get that whole thing divided by 2, which you can split as FC over Q plus VC over Q, and FC over Q is AFC, VC over Q is AVC, so that's how you can come up with this equation. So you technically don't need to memorize it, you can come up with it, but now that you've seen it, you can use either one depending on what you need for that problem. Those are the average costs. Now, marginal cost. You kind of know that that's how much it's going to cost you to make one more fork, right? One more. So that's the change in total cost, how much your total cost changes by when you make one more. So that's change in total cost over change in quantity. Now there's actually two other formulas that also equal marginal cost. Marginal cost also equals change in VC over change in Q. Because technically, this isn't saying that VC and TC are the same thing. Clearly they're off by the fixed cost, right? They're not equal to each other. But the change in total cost must equal the change in VC, because FC can't change. If you made more forks, the change in your total cost of fork production is however much your variable cost changed, because your fixed cost must not have changed when you made more forks. So that's why these two are going to be the same number. So you can use either one. And this is technically also equal to wage over MPL. And where that formula really comes from is let's say you wanted to make one more fork and you're wondering, what's my marginal cost? How much is it going to cost me to make one more fork? Well, technically, you have to hire another worker. So you're going to have to pay them W. That's just the wage that you're paying them. So your cost is kind of W. But that's not just for one fork. That's for however many forks they make. So for example, let's say you're paying your workers $10, so the wage is 10. But that worker, let's say, made 10 forks. Well, then their MPL, what does MPL mean again? It's how many forks the last worker makes. So then that's divided by 10. So you basically pay the worker $10 to make 10 forks. So it's kind of like saying the marginal cost is $1, right? For one more fork, you can say it costs you $1 to make it. So that's where that formula comes from. Now, finally, another formula is that the variable cost is equal to the sum of marginal costs. Now, this formula is weird. I mean, this notation sigma, that just means adding up all the different marginal costs. The way to make sense of this formula is this. If we were the first economists in the world and we wanted to figure out, hey, what are your total costs? Well, one way to think about it is, well, your total costs are your fixed costs, you know, how much rent we're paying in our factory, plus how much it costs to make the first fork, plus how much it costs to make the second fork, plus the third, plus the fourth, and so on. So really, then if we just add up all the marginal costs, that plus the rent we paid at the beginning, that's your total cost, right? That sort of captures every cost that we have. Now, comparing this formula to this, that must imply then that, all right, if you add up all the marginal costs, that must be your VC. So that's that. Now finally, if we were to look at these, the average total cost, average variable cost, average fixed cost, and the MC, these four, I mean, just if you're looking at the formulas, which one looks like it's the odd one out? Well, the MC clearly looks like it's the odd one out. These are all something over Q. This is changing something. But when we graph them out, it turns out that the odd one out is AFC. If we were to look at the graph of AFC, we'll find that it actually is always decreasing, like this. The reasoning is this. The formula for AFC is simply FC over Q. Now the x-axis is quantity. And the FC, the fixed cost of your rent, is a fixed amount. Let's say your rent is $1,000. Then, in that case, what is your AFC if you were to just make one fork? Well then, $1,000 over 1, that's $1,000 average fixed cost. But if you were to now just make 2 forks, well, it's still $1,000. It's still the same numerator, but now divided by 2. So now the average is only 500. And so on. As you increase your Q, meaning moving to the right, that's a lower AFC. So that's why AFC keeps dropping. But if you're looking at the other ones, as you increase your Q, you're also increasing your variable costs and your total costs. And so the numerators also will go up when the denominators do. So it's unclear whether it's going to always go down and go up or whatnot. Now the marginal cost, usually that's kind of like the supply curve which we've been talking about. Now we said that the MPL usually decreases, workers become less productive. As a result, you usually have that the MC goes up. The more you want to make, it's going to cost you more and more to make each extra one because, you know, you're paying the worker the same amount, but they're becoming kind of, you know, not as productive. So really, on average, it's, marginally, it's going to cost you more and more to make one extra fork. And so that's the marginal cost. It drops a little bit. At first, you know, there's some sort of specialization. You know, two workers will probably be a lot more efficient than one worker because they can specialize. So that's why MC drops a little bit. You're getting, you know, lower costs. That's good. But then they start getting each other's way. That's sort of too many chefs in the kitchen. So if you have too many workers, they're sort of butting in each other's way and MC goes up. So it's U-shaped. The other two graphs, AVC and ATC, are also U-shaped. But here's the important relationship between them. AVC looks like this. It's U-shaped, and its minimum is where it intersects with the MC. ATC has the exact same thing. It's always above the AVC, but it's also U-shaped and minimized when it intersects with the MC. Notice also that the gap between AVC and ATC gets smaller. They get closer to each other because their gap is AFC, because AFC and AVC add up to ATC. So their gap is AFC, and AFC keeps shrinking. So that's why their gap keeps shrinking as you move to the right. Now, the important relationship here is this. It's that whenever the marginal cost, one more, is less than the average. So here at the beginning, until they intersect, so let's just focus on AVC for now. Until they intersect, the marginal, the red line here, is below the black line here. And so that's why the marginal is less than the AVC. So when that happens, the AVC, the black line, is decreasing. AVC decreases. And same is true for ATC. If MC is less than ATC, ATC decreases. Now, rather than memorizing this is actually a law that's true not just in economics, but in the universe. So let me give you another example where it'll make more sense, an analogy. Let's say you have a group of 20-year-olds, people who on average are 20 years old. You have a large group of them. Now, what happens to the average age of that group when you add a 12-year-old to the group? Well, the average is going to go down a little bit, right? Well, that's because the marginal value, the one that was added, the last one, the next one, $12 12 years old, was less than the average. So anytime the marginal value, the one being added, is less than the current average, it's going to pull the average down. So the marginal kind of drives the average. So that's why if you look here, if the marginal cost, the cost of making one more fork, is less than the average, that's going to bring the average price down. But then after they intersect, now the marginal, the red curve, is above, and that's going to bring the average up. If you add a 40-year-old to the group of 20-year-olds, it's going to bring the average age up. So that's that relationship over there, and same is true for ATC. Finally, let's talk about returns to scale. The word scale comes from when you're trying to scale up your business, so increasing your outputs and whatnot. So here's a question. Let's go back to that Ford example. Let's say you know that 10 workers and 10 machines gets you 1,000 trucks. Here's a question for you. What if you then double the amount of workers and machines that you have, all of your inputs? So now you have 20 workers instead of just 10 and 20 machines. How many trucks do you think you're going to have? It's actually, we can't tell. It kind of depends. What if you get exactly 2,000 trucks? That's kind of what you'd expect, right? If you have twice as much, if 10 and 10 made you 1,000, then, if the extra workers and the extra machines kind of added the same amount as the previous ones, well then, you're going to have exactly 2,000, right? But you might not. You might have less than 2,000, or you might even have more than 2,000. If you have less than 2,000 as your output, then that's called decreasing returns to scale. Decreasing returns to scale. Now, if you have, on the other hand, exactly 2,000, that's called constant returns to scale. And finally, if it's more than 2,000, then that's increasing returns to scale. Now, so if we wanted to generalize, it's kind of like saying if you were to double all inputs, and technically you can say triple all the inputs or whatever, if you were to double all inputs, and if you more than double your output, that's increasing returns to scale. If you exactly double it, that's constant, and if you less than double your output, then that's decreasing returns to scale. Now, if you have decreasing returns to scale, that's also going to have increasing cost. So it's kind of the same thing to say that, my company has decreasing returns to scale, meaning when I scale up, I double all my inputs, I'm actually going to, they're sort of not as productive, so I'm going to less than double my output. That's decreasing returns to scale or increasing cost. Your average cost will go up. Your LRATC, your long run average total cost, in this case is increasing. In this case it's constant, and in this case it's decreasing. So it's kind of like the opposite. Here, if your workers are productive, increasing returns to scale, that's going to be decreasing cost. So here this is decreasing LRATC. So that's what returns to scale is. So now let's look at a question from a student. Why does the MC curve slope upward? I'd think that you'd get more efficient as you make more cars, and it would cost less to make one more. Now, that's a great point. As we make more cars, you'd think that you're getting better at it, efficient, it's going to cost you less to make one more. Here's the thing. The MC curve that we see, that's for the short run. Almost every curve that you've seen so far has been for the short run, And what that means is in the short run, you cannot change your capital. Most things are fixed. You have some fixed stuff that you can't control in the short run. So if you only have one factory for Ford, and if you only have one sort of machine or a fixed number of machines, the only thing, if you want to make more cars, you're just going to have to hire more and more workers. And as that happens, because the MPL goes down, too many chefs in the kitchen, extra workers make fewer and fewer. That's why it's going to cost you more technically in the short run to make an extra car, when everyone's getting in each other's way. That's why it goes up. Now, of course, in the long run, when you're able to, change up everything, you're able to be more flexible, then you actually can have lower average costs on average of making more and more. And that's actually what we looked at the very end, the returns to scale. On average, Ford, as they sort of have an assembly line and all that stuff, they're going to have, decreasing average costs in the long run. So that's increasing returns to scale. So what you're thinking of there is, in the long run, your cost on average goes down for making an extra unit. But in the short run, we're assuming for this class that since you can't vary stuff, that's why it goes up. And finally, here's another question. Can the AVC and ATC curve ever intersect? Good question. Now, we know that the MC curve obviously intersects with both the ATC and the AVC when they're minimized. But the AVC and ATC curve, they can actually never intersect with each other. In fact, as we kind of saw, the ATC is actually always above the AVC by the amount of the average fixed cost. That's why it can never really meet. There's always going to be that gap. As long as there's some fixed cost, the average fixed cost will always be the difference. Now, on the other hand, one sort of exception is if there are no fixed costs. If you're in an industry with no fixed costs, well then it's not so much that they're intersecting, but if there's no fixed costs, the variable cost is the total cost, and so AVC and ATC are the same curve. Well, I hope you now understand economics better, and if you really want to make sure you've mastered the concepts, check out our active learning customized platform at bestecontutor.com. It's like having a one-on-one tutor right in front of you 24/7. You can click here to try it out for free. And we'll be adding more topics and videos on YouTube, so make sure you subscribe below for the latest updates.